Yeah. So, hello everyone. Yeah. Just a second. Yeah. So, hello everyone. This is Arpit, and I'll be TAing for the course Biostatistics and Design of Experiments. So, in today's session, let me just admit everyone. Yeah. So, in today's session, we'll discuss a bunch of questions from previous year's assignments, and we can then, after that, discuss any doubts that you have regarding the assignments or the course. So, can everyone hear me?
Yes.
Yeah, thanks. Can you also see the screen?
Yeah, visible.
Yeah, okay, thanks. Yeah, so we'll just start, or do you want me to wait a little bit more? If people are still joining.
I think we can wait for a minute.
Yeah, sure. So as we go through the questions, if any one of you has any doubts, you can unmute and uh,
Uh, I
ask me
have
to
a
explain.
question regarding the first assignment, question regarding the mode. And what, as per my understanding, the answer is 13 and 14. But the answer sheet for the software is not allowing to put a comma in between. So I cannot write the correct answer.
Okay, so we are asked not to discuss this year's assignment, but I can explain to you what the mode exactly is. So the mode is like the number. So in a set of numbers, the mode is a number that appears the most number of times. So can you
Yeah,
give me a
but
list?
yes,
Yeah.
your answer is correct, but the questions what is asked have a two mode.
Okay. So can you give me the?
Give me a minute, then I'll open my sheet and
Yeah,
yeah,
I'll also check. Yeah, I'll
discuss
also.
that point.
Yeah, yeah. I'll just take a look at the assignment also. Yeah, Sonali, you can unmute and talk.
Yes, yes. So I number five.
It's not clear what you're trying to say. Hello?
Can you, hello,
Hello?
Arpit, can you hear me?
Yeah, I can hear you now. Yeah.
Hello.
Yeah.
Yes, I'm unable to solve problem number 5
Okay,
from
so
assignment number.
assignment number? Can you just type it in the chat box? I'm not able to hear you properly.
Yes.
Yeah. Okay, Jagdish, yeah, I think I get your point. I'll talk to the instructor about it. Yeah. There are two modes, right? Yeah.
Thank you.
Yeah. Yeah. Sonali, we'll discuss similar questions, previous assignment, which has very similar questions. So I think after that, you'll be able to solve the assignments. Yeah. So I
Hello,
think we can, sorry. Yeah.
sir. I'm Anandakrishnan. Sir, I have a problem in doing the first question of the week one assignment.
Yeah. We'll discuss similar questions. After that, I think all your doubts should be cleared. Okay. So yeah, we'll start now. Is everyone able to see my screen?
Yes, sir.
Okay. Yeah. So uh, yeah, so we are solving a previous year's assignment. So the first question here is, if drug A has 75% success and drug B has 55% success, and both the drugs are given to a patient, what is the probability of both the drugs failing in percentage? Second, I need to add a few more people. Yeah. Yeah. So what is given is the probability of success of drug A, that is 75%, and the probability of success of drug B, that is 55%. Okay, now we need to calculate, since we are talking about drugs failing, we need to calculate the probability of failure. So the probability of failure of the drugs is basically 100% minus the probability of success. So for drug A, that will be 100% minus 75%, which is 25%. And for drug B, that will be 100% minus 55%, which is 45%. Right. Then we need to find the probability that both of the drugs will fail. So probability that both of the drugs will fail is equal to the probability of the drug A failing and the probability of the drug B failing at the same time. So that is the probability of failure of drug A multiplied by the probability of failure of drug B. That's 25% into 45%, which comes out to about 11.25%. So the answer is 11.25. So the two people, I guess, Biswajit and Sonali, you had doubts in the first question, right?
Yes, sir.
So now do you understand like how it's supposed to be
Yes, I
done?
understand.
Or like if you have any more doubts or if you need any more clarifications, you can ask.
Arpit, can you hear me?
Yeah, I can hear you.
Yes, I have a doubt regarding question number 5.
Question number, oh, sorry, yeah. We'll come to that. So,
Yeah.
yeah. Next is, so for question number 2, the question is, we are conducting a clinical trial for a viral load lowering drug. In addition to the test group who are given the drug, what other group or groups should be present in the trial? So the options here are, there should be a placebo group only. So a placebo group is a group that is given a sugar pill basically. So they are given something that resembles the medicine but is not the medicine. Okay. So the second option is there should be a control group. So the control group is a group which is not given any medicine, but they follow the basic same routine that the other groups follow. Like, for example, the diet, sleeping patterns, and stuff like that. So the third option is there should not be a control group, but a placebo group. And the fourth option is there should be a control group and a placebo group. So the correct answer here will be option D. So ideally, if we are conducting a clinical trial, we are supposed to have 3 groups. So first group is a control group who are not given anything. So the second group is a placebo group who are given something resembling the drug, but which is not the drug. And the third group should be the test group, which is given the drug. So we have these 3 groups to, so if we make pairwise comparisons between the control group and the test group, we can find out that if the drug works, irrespective of any of the sleeping patterns or diet patterns that the participants follow. And the placebo group is there because like we want to see if the medicine really works, or if like the fact that we are giving a medicine to people is kind of doing its job. So sometimes what happens is when people believe that they're given some medicine, they tend to get better without even getting the medicine, right? So that's why we have three groups in every clinical trial to test the efficacy of a drug. So does anyone have any doubts regarding to this? Okay. Just a second. A few more people joining. Yeah. So yeah, we'll move on to the third question. So third question is,
Hello.
yeah.
Sir, will you please repeat first question, first problem?
Yeah, sure. So
Yes,
the
sir.
first
Thank
question is, we are given two drugs. Drug A has a probability of success that is 75%, and drug B has a probability of success that is 55%. We have to find what is the probability of both of the drugs failing if they are given to a patient. So we know that the probability of success of the first drug is 75% and the probability of success of the second drug is 55%. Then we need to calculate the probability of failure, which is nothing but 100% minus the probability of success. So for drug A, that comes out to be 100 minus 75, which is 25. And for drug B, it comes out to be 100 minus 55, which is 45. Now, to know if the drugs are simultaneous, so to get the probability that the drugs are failing simultaneously, we need to multiply the probability of failure of both of the drugs. So the probability that both of the drugs will fail is equal to probability of failure of drug A multiplied by the probability of failure of drug B. So we have 25% multiplied by 45%, which comes out to be 11.25%. Is that clear?
Yes, sir. Yes, sir. Thank you.
Yeah. Okay.
Yes, sir, clear.
Yeah.
Good evening, sir. I have just joined the meeting. Hello.
Yeah.
Yeah, sir, can I know as to which week discussion is going on?
Oh, sorry. Yeah. So for everyone who has joined the meeting now, so we are solving a previous year assignment, which is similar to the assignment that you are given right now for week 1. So we are not allowed to solve the current assignments till the due date is gone. So we have a bunch of questions that are very similar so that it will help you understand how to solve the assignment questions.
Okay, sir. So now we are in week one assignment. Similar questions on lines on similar.
I couldn't hear that. Can you?
So right now we are on discussion with week one assignment, which
Yeah.
are having questions on the same line. Am I correct?
Yeah.
Thank you, sir. Thank you.
Yeah. So does everyone understand the first question and how to solve it?
Yes.
Yeah.
Okay. So I'll repeat the second question again. So we are conducting a clinical trial for a drug. So we have a test group, and the question asks what other group should be present in addition to the test group. So the correct answer here will be group answer D, which is there should be a control group and a placebo group. So we have in every clinical trial, we have three groups, a control group, a placebo group, and a test group, so that we can make pairwise comparisons and assess if the drug is actually working. So the yeah. So the role of the control group is to see if the behavioral patterns of the patients, like sleeping patterns or eating patterns, are the reason for any change that we observe. So the control group has no drug, but it follows the similar pattern to the test group so that we know it's not an effect of the pattern. And similarly, we have a placebo group to see that if the drug actually works when compared to a placebo, which is like a sugar pill or something. So sometimes what happens is the action of giving a medicine to someone kind of cures them because they mentally feel like they're given something that will help them. So we want to see if a drug really works or if it's just the effect of the placebo. So that's why we have 3 groups in every clinical trial. Right. So yeah, we were on the third question. We'll continue from here. Yeah. So we are testing if drug A is more active than drug B. So we need to pick out a statement out of all these which is correct. So in hypothesis testing, we have in general 2 hypotheses. H naught is the null hypothesis. That's the hypothesis of no difference. That's the hypothesis that is kind of accepted in general. And then we have an alternate hypothesis, which is called HA, which is the hypothesis that we want to check. So here we want to check if drug A is more active than drug B. So our null hypothesis should be that both of the drugs act similarly. So the null hypothesis will be drug A, like action of drug A is equal to action of drug B. And the alternate hypothesis should be drug A is greater than drug B because we want to check if drug A is more active than drug B. So the answer to this question will be option C. H naught is drug A is equal to drug B and HA is drug A is greater than drug B. Is that clear for everyone?
I just had a query to this, if I may just ask.
Yeah.
Yeah. The thing is, from what I have read in statistical research methodology, etc., books, I
Yeah.
understand that like alternate hypothesis is not directional usually. So I was just a bit, when I saw a directional statement mentioned like this, I was just curious to know.
Yeah. So there are all kinds of alternate hypotheses that we test. So later in the course, when we get to t-tests and stuff like that, we'll see things like one-tail test or two-tail test. So generally, if we want to check a directional effect, we use a one-tailed t-test or a one-tailed z-test or something. But if you want to
Yeah.
see a non-directional effect, then we use a two-tailed test. So
Where
here,
only
sorry.
the first statement would, I think that, yeah, the first option would have held good in that case if it was
Yeah.
bidirectional. Yeah.
Yeah. For a bidirectional test, we generally have different set of tests. So those are called like two-tailed tests. So which see if there is a difference or not. But there are some other tests, one directional tests, where we can see the difference is in which direction. So is it a positive difference or is it a significant negative difference?
Thank you.
Excuse me, sir.
Yeah.
Hello.
Yeah.
Sir, मेरा question, can I speak in Hindi, sir?
Yeah.
सर मेरा क्वेश्चन ये है कि सर ये वाला जो क्वेश्चन है, ये जो आपका फर्स्ट वीडियो थे सर, इसमें समझ में नहीं आया कि किससे रिलेटेड था,
समझ नहीं आया क्या?
किस वीडियो से रिलेटेड था ये वाला क्वेश्चन, 3rd नंबर वाला?
ओके, सो
किस चैप्टर से था सर?
ये किस चैप्टर से था? ओके, सो ये जनरल एक्सपेरिमेंटल, सो 4 वीडियोस है,
जी
एक एक्सपेरिमेंटल डिजाइन और 3 डिस्ट्रीब्यूशन के. सो ये एक्सपेरिमेंटल
जी
डिजाइन वाला है, सेकंड वीडियो, वीक 1.
ओके सर, थैंक यू.
Yeah, this is from the second video of week 1. Yeah.
ओके सर, थैंक यू.
Yeah. So Tafazul, yeah. So when we say that drug A is not equal to drug B, we mean that the action of drug A is not equal to drug B. That either drug A is more effective than drug B or less effective than drug B. So when we say drug A is equal to drug B, we say that both of them are equally effective. When we say drug A is not equal to drug B, we are meaning that one of them is more or less effective than the other. And when we say drug A is less than drug B, we mean that drug A is less effective than drug B. And when we say drug A is greater than drug B, we mean that drug A is more effective than drug B. Okay. Is that clear?
यस सर, क्लियर.
Yeah. Okay. So the fourth question we have, the probability of congenital blindness is 1 out of 8. What is the probability that 3 persons in a family of 10 have that disease? So in questions like this, we will assume that it's a binomial distribution because we are given a fixed probability of a person having congenital blindness or not. And we are testing if like 10 members, we can take them as independent sets because like it's not related to anything, any complicated genetic things for now. And we need to find out the probability that 3 of the events are happening. So we are given that the probability of congenital blindness is 1 by 8, which is 0.125. And we can assume that it's based on a binomial distribution. And we are just, it's like tossing a coin 10 times and getting 3 heads or something like that. So here we have k is equal to 3, where k is the number of times the event happens. Here the event is getting congenital blindness. N is 10, which is the number of trials, which is the number of like number of persons in the family. And P is the probability of congenital blindness happening. And then using the formula, we can see like inputting the value N is equal to 10, K is equal to 3, and P is equal to 0.125. We can calculate the probability. So it's like 10 factorial by 3 factorial multiplied by 7 factorial into 1 by 8 to the power 3 multiplied by 1 minus 1 by 8 to the power 7. So the answer comes out to be 0.092. Is this clear for everyone?
Yes, sir, clear.
I have one
So one
question.
doubt, sir, whether if we are putting these values in graph pad, whether we have to take the cumulative or exact probability.
Okay, it's not kind of clear. Can you speak a bit more loudly?
Sir, it's like if we take this values and put it in a computational method, like in graph pad, if we are using graph pad and putting this value there, whether we need to consider the cumulative one or the exact probability here.
Yeah, so the question is, what is the probability that 3 persons have the disease? So we'll use the exact probability. If the question was, what is the probability that at least 3 persons have the disease, or at most 3 persons have the disease, then we would use a cumulative probability.
Okay, okay. Thank you, sir.
So for
Got it.
cumulative probability, it just adds up the probability of the previous numbers. So if we say what is the probability that at most 3 people have this disease, then we'll take the probability of 1 person having the disease plus the probability of 2 persons plus the probability of 3 persons. Then it adds up. So that's the cumulative probability. But in
Okay.
this case, we are just checking the probability for 3 persons.
Thank you, sir.
Yeah.
Okay, sir.
Dr. Pritpal, are you trying to say anything? It's not quite clear.
Yes, I was having a question that can we solve the same thing by using Poisson's distribution?
Can
Or
we
no?
solve the
Same thing by using Poisson's distribution?
Poisson distribution?
Yeah.
Yeah, ideally we can solve the same thing using a Poisson distribution, but since the numbers here are quite small, so it does not make a lot of sense to use a Poisson distribution.
Okay, so the sample size should be large for using Poisson.
Yeah, so for Poisson distribution, the probability needs to be quite low, and the multiplication of n and p should be a large number. That is the mean in a Poisson distribution. That should be a large number, and the probability of a same individual event happening should be quite small. Here, the probability is 0.125, which is not that small. So unless like you're asked to use a Poisson distribution, I don't think it's necessary.
Okay, sir.
Yeah. Okay.
Sir, in the examination, could we use calculator to solve these numericals?
So I am not sure about how the examination works, but I don't think they will let you use a calculator. I'm not sure. I can
From
ask it and we can discuss
what
more
I
about this in the discussion forum. Yeah.
observed, there is a calculator attached to the screen.
Okay.
This was
Yeah.
happened to take a maths-based course earlier. So there
Yeah.
is a calculator attached to the screen. That's
Okay.
to the computer.
Yeah. So then I
In
guess you're
line to
allowed to use
this,
a calculator.
in line to this, is the Excel sheet is allowed to use? Because this is online
Yes.
exams.
Yes, attached to the system, you have the calculator enabled.
Same Excel is also enabled.
Sorry, not Excel.
Only
On that
calculator.
occasion, Excel, I don't think, but calculators, yes. I'm not
Okay.
sure about Excel because that particular exam we didn't need. Anyway, I think as they said, I think we'll check that in the discussion forum.
Yeah. So
Arpitji, if you provides the informations, clear information that Excel is available or not, then it is benefited to us to how to work for the exam actually.
yeah. I'll ask that and I'll let you know in the next class probably. Is that okay?
Yeah.
Yeah. So I have taken a few courses, but I have never given a certificate exam. So I don't know how the exam exactly works. So yeah, I'll ask around and I'll let you guys know. Okay. So we'll continue to the next
Sir,
question. Yeah.
about the last problem, if we calculate the probability by Poisson, so the answer is not correct. Is by using that Poisson distribution.
By using a Poisson distribution.
Yes, sir. Same problem I have calculated with Poisson distribution. So whatever the answer, it is whether it is correct or not. Is right there.
Let me just check. So for the case of the assignment, I think it won't be accepted if it's not close to this value. What is the answer that you got using Poisson?
Uh, According to assignment, I got the answer 0.6688.
Yeah, I think that won't be accepted
In assignment.
in assignment.
Huh.
In the current assignment.
Yes, sir. In the current assignment, I got the answer 0.6688.
Yeah, so we are not using the current assignment question, so the values here are a little bit different. I can still
Yeah, you
check.
get the different value with the binomial equation because I already said, but in this forum I cannot answer what is the exact value. So I think
Yeah.
this is Excel based exam and instructor put at the fixed value. So I don't think that accepted by the instructor.
No. So for this question, you need to use the binomial distribution because they have an automatic checker that uses the binomial distribution to get at the answer. Okay.
Okay, sir. Okay.
Yeah. Also, like it's
Thank
not correct to use a Poisson distribution if the probability is not quite low and if the sample size is this small. For a general rule of thumb, if the sample size is less than around 100 or 50, it's a good idea to use a binomial distribution.
Yes, sir.
Yeah. So for question number 5, the question is, a drug is being tested for curing ovarian cancer with a mortality rate of 9%. What is the minimum number of patients required to demonstrate the efficacy of the completely curative drug at 95% confidence interval? So we are given that the mortality rate is 9%, which is 0.09. So the survival rate of the disease, so if a person gets the disease, what is the probability that they will survive, is 1 minus the mortality rate, which is 1 minus 0.09, which is 0.91. So if we have n number of individuals, what is the probability that all of them will survive naturally without any disease? So that is 0.91 into 0.91 into 0.91 n number of times. So that turns out to be 0.91 to the power of n. Okay. For 95% confidence interval, we need a survival rate that is lower than 1 minus 95%, that is lower than 0.05. So if the natural survival rate is lower than 0.05, then only if no one dies in the trial, we know that the drug is completely curative. Otherwise, if like the survival rate is greater than 0.05, we won't be able to tell if the drug is working or if the person survives just because of natural chance. So I think this part is the critical part. Does everyone understand why we are taking 0.05 and
Yeah.
what we are trying to do?
But sir, why we have taken log value?
Sorry,
We taken log value.
can you speak a bit louder? I can't hear you.
We have taken log value. Log values. Log.
Yeah, that part I'll come to. But do you understand why we take this equation that's 0.91 to the power n is less than 0.05? This part. This
So
part
that
everyone
is, sir,
understands, right?
Yeah, that's a
Yes,
basic
sir.
log rules.
Sorry?
Yeah, that's we understand basic log
सर
rules.
एक क्वेश्चन कहाँ से आई सर?
This is previous year assignment. 2022.
सर ये क्वेश्चन कहाँ से आई? 0.91 to the power n is less than 0.05.
Equation. That is what I'm asking. So we know if someone gets the disease, there's a 9% chance that they will die. So the chance that they will survive is 0.91%. So that is 0.91. And if we have n number of individuals, the survival rate of all of those individuals is 0.91 into 0.91 into 0.91 n times, which is 0.91 to the power n. This part you understand, right?
Yes,
How
sir.
we get this part? Okay. Now we have a completely curative drug. So the drug can
Sir,
cure the disease. Sorry.
the doubt that how we can say that the survival rate should be lower than 0.05 for the in 95% confidence.
Yeah, that part I'm coming to. So we know that the survival rate for n individuals will be this. Okay. Now we are trying to see what will happen. Now we are trying to test a drug that is completely curative. So that means if anyone who has the disease is given the drug, they should be cured, right? So this survival rate, this is the natural survival rate. It should be less than the confidence interval that we are trying to test. So we are trying to test for a 95% confidence interval. So we need the survival rate to be lower than 1 minus 95%. So if this survival rate, if the survival rate is less than 0.05%, that means key less than 0.05% of the times the people will die. So 95% of with a 95% confidence, we can say that someone who has a disease will die. Like, so let's say we have n number of individuals. Okay. The survival rate here will be less than 0.05%. So the rate of death will be 95%, greater than 95%.
Okay.
Okay, sir. Okay, good.
Yeah, that part you understand, right? So after that, it's just because we have a power here, that is n, we take a log on both sides. So the n comes outside, then we get n log 0.91 is less than log 0.05. And because we are taking log of fractions, it will come out to be negative. So when we divide both sides by, sorry? Does anyone have any doubts?
Yeah, hello.
Yeah.
My name is Kalram Makwana,
Yeah.
and I have a doubt about the first question. Like, if a drug A has a 80% success and drug B has a 65% success, and then what would be the probability of both drugs for failing in percentage? So I just
Yeah.
want to know what will be the calculation here.
What will be the
Kalrao,
Calculation. I
that's
don't
part
want the
is
answer.
Kalrao. I am knowing this guy. Sorry, Arpit. Kalrao, this question is already covered, so I'll
Jagdish
explain
bhai,
you.
I joined recently, but I want the explanation from them.
Yes,
So
that's already
okay. Yeah.
Kalrao,
After
that's
this,
explained very well by the Arpit bhai. So I'll explain you also.
we'll
I
no,
hope
but
visit
I
the
that
want to
first question
explanation
after we
from
are
him
done.
also.
So for people who have joined later, after we go through all the questions, if you have any doubts with questions that were discussed before you came, we can go and visit them again. Is that okay? Yeah. So here we take log on both sides, and because log of a fraction is negative, so when we divide log 0.91 on both sides, the sign kind of changes. So here we have the n value should be greater than log 0.05 divided by log 0.91, which turns out to be 31 point something. So the answer asks for a whole number. That's why we have 32.
Okay.
Yeah. So for people who have joined now, we'll go through all the questions. And if you have doubts in any of the questions that were discussed before you came, we'll go back to the questions after that. Okay. So the sixth question is, the probability of a birth defect is 0.11. What is the probability that no one in a family of 15 people will have that birth defect? Here we are explicitly asked to use a Poisson distribution. That's why we'll use a Poisson distribution. So the probability of a birth defect is given to be 0.11. So the formula for a Poisson distribution is probability of x given the lambda or mu is equal to e to the power minus lambda into lambda to the power x whole divided by x factorial. And lambda is given by n into p. Here we have n is equal to the number of people in the family, which is 15, and p is the probability of the birth defect, which is 0.11. Therefore, lambda is 0 p into n, which is 0.11 into 15, which is 1.65. Then we are asked what is the probability that no one in the family has the birth defect. So the probability that x equal to 0 given lambda is equal to 1.65 is equal to e to the power minus 1.65 into 1.65 to the power 0 divided by 0 factorial, which turns out to be 0.19205. So the answer is this. Does anyone have any doubts in this question?
No, sir.
Yeah. Also, Sonali, you had a doubt in the fifth question, right? Is that clear now?
Yes, it is clear to me.
Okay.
Thank you.
Arpit, how to get a value of e raised to minus 1.65?
So you have a calculator, right? And as someone pointed out, I guess
So scientific calculator will be allowed during the examination for some sort of things.
Yeah, I'll ask about the calculator and Excel sheet, and next class I'll say, or maybe I'll mention something in the discussion forum. Okay. Yeah. So the seventh question is 1650 red blood cells were counted per 1 ml of blood. What is the 95% confidence lower limit for the patient's true red blood cell count?
Arpit,
It's
may
upper
I ask
limit. It's
you a
upper
question?
limit.
Yeah.
A previous question, actually, I have a small clarification. Like, for example, in the binomial distribution question, that there were very small number of people, that is totally 10 only. Whereas in this case, only 15 people only. But here in this question, it has been mentioned Poisson distribution. So we are going for the Poisson distribution calculation. How in case if the question is not given, whether it is a Poisson or binomial, on which basis that we have to decide enough number that from where we have to go for binomial or Poisson?
So generally, when you have a very small probability, let's say something like 0.000 something, and a very large n, let's say 1000 or 10,000, that's when you go for a Poisson distribution. If it's a very small n or a very large probability, then you go for a binomial distribution. Is that clear?
Is there any limits like that, where you can beyond which you have to go in for a Poisson distribution, like greater than 30 or anything like that?
Yeah, so there are no basic hard limits on that. The general use case is like if you have a very small probability, which is very difficult to calculate using a binomial distribution, because in a binomial distribution you have a lot of powers, and if you have a very small value, the powers tend to make the probabilities even smaller. So essentially you get a zero probability. So that's something that we want to avoid.
Okay, thank you.
Sir,
Yeah.
when we use binomial distribution,
Yeah. I didn't get that. Could you repeat?
sir, when we use binomial distribution,
So a binomial distribution is used when you have a set of repeating events which are independent of each other, and the probability of each of the events happening is constant. So let's say you are tossing a coin 100 times and you are trying to get what is the probability of getting a heads. So the probability of getting a heads in each toss is fixed, which is 0.5. And you're tossing a coin for 100 times. So those are like 100 different independent events that you have. In that case, if you want to know like how many of these tosses will be heads. So let's say you want to find the probability that 10 of the 100 tosses are heads, then you will use a binomial distribution. Is that clear?
Yes, sir.
Yeah. Okay. So we'll move on to the seventh question. So 1650 red blood cells are counted per 1 ml of blood in a patient. What is the 95% confidence lower limit for the patient's true red blood cell count? So we are given a count value, which is 1650. And because we are working with count values, we use a Poisson distribution to calculate the confidence interval around a point data. So there's a direct formula for calculating the confidence interval of a Poisson distribution, which is L plus minus T multiplied by root over of L, where L is the count or the value that we have, and T is based on the confidence interval that we are trying to calculate. So for a 95% confidence interval, a T value is 1.96, and for a 99% confidence interval, the T value is 2.58. In our case, the T value will be 1.96. So the confidence interval will be 1650 plus minus 1.96 into root over of 1650. Yeah, there's a typo here. It should be a root over of 1650. So we get the range, that is 1650 minus 79 plus 1650 plus 79. So the range is from 1570 to 1730. So confidence interval is basically a range around our sample, so that it says like if we take the sample again, what is the range in which we'll get the value. So let's say we were to take blood again from this patient, we might not exactly get 1650, but with a 95% confidence, we can say that we'll get something between 1570 to 1730. Or in other words, if we take blood of this patient 100% of times, like 100 times, then in 95 of those cases, we'll get a value which is between 1570 to 1730. Since we are asked for the lower limit, we'll choose 1570, and that's the answer for this question. Is that clear for everyone?
सर
Yeah.
हेलो
Yeah.
सर ये जो आपने 1.96 मल्टीप्लाइड बाय 1650 किया है ये क्या है सर?
So to calculate the CI confidence interval calculate करने के लिए we have a formula, that is count plus minus
Okay,
T
sir.
into root over of L. So I just put that formula, and here there's a typo. There should be a root over here. So this is root over of 1650.
ओके सर. ये मल्टीप्लाई में समझ रहा था सर.
Yeah.
ये मल्टीप्लाई नहीं है सर.
हाँ, ये multiply है. The star is multiply.
ओके सर.
Yeah.
Okay, sir. Thank you.
Yeah. So the eighth question is, what is the mode for the set of data 14, 13, 18, 13, 16, 14, 18, 16, 14, and 20? So a mode is the value that appears most often in a set of data. So here we can count 13 appears 2 times, 14 appears 3 times, 16 appears 2 times, 18 appears 2 times, and 20 appears once. So we know that 14 appears 3 times, which is the most number of times a given number appears in the data set. So the answer is 14.
Sir.
Yeah.
Sir.
Yeah.
सर अभी जो लेटेस्ट असाइनमेंट है सर, तो उसमें दो 13
हाँ
और 14 दोनों
हाँ
तीन
हाँ
तीन
हाँ
बार है सर,
हाँ हाँ
थ्री
yeah,
टाइम्स है सर, तो उसका
yeah,
आंसर कैसे निकालेंगे, किस फॉर्मूले से?
I'll talk to the instructor. So someone else was pointing out, I guess Jagdish, that he was not able to use a comma. So I'll talk to the instructor and I'll get back to you what you have to do. Or if they have to change the submission guidelines, they can change it. Is that okay?
ओके सर,
Yeah.
ओके सर.
Yeah. So the ninth question is, in a normal distribution curve, 2 sigma represents what percent of the area? So for a normal distribution, in a given range of sigma, there are specific percentages of area that are represented. So in within 1 sigma, we have 68.2% of the whole curve. Within 2 sigma, we have 95.4% of the whole curve. And within 3 sigma, we have 99.7% of the whole curve. So that's how the normal distribution is kind of defined and standardized. So the answer here will be 95.4%. Is this clear?
सर मेरा डाउट है सर, इसमें 2 सिग्मा प्लस की तरफ मांग रहा है, तो 2 सिग्मा दोनों होगा क्या, प्लस माइनस?
Plus minus होगा. So if a question does not mention specifically, if you have to calculate the area from 0 to 2 plus 2 sigma or from 0 to minus 2 sigma, you assume कि it's the area between minus 2 sigma to plus 2 sigma.
So can you please repeat again?
Yeah. So which part do you want to repeat? The part I said now or the earlier one?
The previous one, the question.
Yeah. So the question says, in a normal distribution curve, 2 sigma represents what percent of the area?
Fine.
So a normal distribution curve is defined such that the area under 1 sigma, that is area from minus 1 sigma to plus 1 sigma, is 68.2%. The area from minus 2 sigma to plus 2 sigma is 95.4%. And the area from minus 3 sigma to plus 3 sigma is 99.7%. So the answer here will be 95.4%.
Thank you, sir.
Yeah. So yeah, this is the last question. So in a standardized normal distribution, what is the area between z is equal to 1 and z is equal to 2.5? So we have a table of z-scores from where we can calculate what is the area of under the curve for different z
Arpit, your
values.
screen is not visible actually.
The graph is not visible.
Yeah.
Yeah, that's okay.
Some other one's screen is visible at present actually.
Is anyone else sharing this screen?
Yeah, even I'm seeing a numerical. Yeah.
Just a second.
Someone is sharing.
Yeah. Can you see my screen now?
Yeah,
That's
right.
what is visible.
Yeah.
Yeah. Can you guys see the table on the right?
Yes, sir. Yes, sir.
Yeah. So here what we need to do, so there are different kinds of tables that will give you different kinds of values for areas under the curve. So in this case, we get the area from the end of the curve to whatever z-score we are trying to calculate. So from this table, we can see that area of 2.5. So because there's no confidence interval that is mentioned, we'll take the first confidence interval, that is 0.0, this first column. So for 2.5, we have area under the curve that is 0.9938. And for 1.0, we have area under the curve, which is 0.8413. Now, all we have to do is to find the area between both of them is subtract area of 2.5 minus area of 1.0, which is 0.9938 minus 0.8413, which is 0.1525. This is the answer. Is that clear for everyone?
Yes, sir, clear.
Yeah. Arpit, here the same question. This table is available during the examination?
It should be. Yeah. You're not allowed to memorize, like you're not expected to memorize a table.
Okay.
Yeah. So someone had a doubt on the first question, right?
Right.
Sir, explain me.
Yeah.
सर अभी सेकंड असाइनमेंट का होगा डिस्कशन, मेरे को एक जगह जाना था सर.
Second assignment will be discussed next week. So there's another
Okay, sir.
session
Thank
by another TA. I think it's on 7th.
Okay, sir. Okay.
Yeah, I'll ask him
Okay.
to if he can cover that also. He's a friend
Okay,
of
sir.
mine. Yeah, I'll ask him if he can cover
Okay,
that.
sir. Sir,
So in
any
the
email
assignment,
ID?
there is no table
Sorry?
visible.
Sir, any email ID given for discussion?
No, everything, anything that you have doubts or anything you want to discuss, you can ask in the discussion forum.
Okay, sir.
Okay. Yeah, we'll respond there.
So,
In
what is
case,
the discussion forum? Can you please tell me? I am not aware about it.
so in NPTEL, you have a discussion forum where you can ask your doubts or questions.
Okay. Okay, sir.
Just a second.
Okay, sir. Thank you.
So,
Actually, sir, last date of second assignment is 8. And discussion in on 7th, sir.
Sorry?
Last date of assignment second is 8. Yes,
Yeah, yeah.
So discussion on 7th.
Yeah. 7th, there's
Okay,
another
sir.
TA session. Yeah.
In the
Okay,
question
sir.
of mode, there are 13, 13, 14, and 14. Which is right?
Yeah. I know. Everyone has that doubt. I think that's an issue. I'll talk to the instructor about that. Yeah. So if you open the course online and if you go to the course outline, there's a section like there's week 1, week 2, week 3. There's a section that says how does an NPTEL online course work, right? There you have a video for discussion forum. You can go through that video that tells you how to use the discussion forum. And then you can ask questions on the discussion forum and we'll get back to you there. Is that okay?
Okay, sir.
Yeah. So, yeah.
Hello, sir.
Yeah.
Sir, after finish the first question, could you explain the second and third question, sir, please?
Yeah. So the first question is, drug A has a probability of success of 75% and drug B has a probability of success of 55%. Both of the drugs are given to a patient. What is the probability that both of the drugs will fail? So we know that the probability of success of both of the drugs, that is 75%, 55%. To calculate the probability of failure, what we'll do is we'll subtract 100% minus the probability of success. That is 100 minus 75 for A, which turns out to be 25, and 100 minus 55 for B, which turns out to be 45. Then, or the probability that both of the drugs will fail will be the probability that drug A fails and the multiplied by the probability of failure of drug B. So what we have here is 25% multiplied by 45%, which turns out to be 11.25%. Is this clear? Yes, who asked the question?
Yes, I asked the question and now it's very pretty clear. Thank you. Thank you, Arpit.
Yeah. So, after the second and third question, we'll go again to the 10th question. Yeah. So the second question is, we are conducting a clinical trial for a drug. There's a test group. What other groups should be present? So in a clinical trial, you always should have 3 groups. One is the control group, one is the placebo group, and one is the test group. So the motive of having a control group is to see whether the drug acts or whether there's a behavioral thing that is affecting the health of the patient. So the control group has everything same to the test group, just it does not have the drug. So they sleep at the same times, they eat at the same times, and they do all the same things, but they don't take the drug. Whereas the test group does everything and also takes the drug. So the motive of having a placebo group is that sometimes what happens is if you tell someone that you're giving them a medicine, that itself is strong enough mentally to help with help them with curing the disease. So sometimes what happens is what some doctors generally do is they give sugar pills to patients who are very kind of irritated or who are like, I need a medicine or something like that. The doctor will just give you a sugar pill and tell you that it's medicine and somehow it works because you believe in it. So that is the effect that we are testing with a placebo group. So with a placebo group, we want to test if the action of taking the drug is responsible for the effect or the drug is responsible for the effect. So the answer here will be D. We should have two groups apart from the test group, that is the control group and the placebo group. Is that clear?
Yes, clear, sir.
Yeah. So for the third question, we are testing if drug A is more active than drug B. So when we do a hypothesis testing, we have generally two hypotheses. One is a null hypothesis, that is the standard accepted thing, and one is the alternate hypothesis that we are kind of testing. So generally the null hypothesis is of no difference. That is, in this case, the null hypothesis will be that drug A and drug B work the same, so that the action of drug A is equal to the action of drug B. Here, since we are testing if drug A is more active than drug B, what we'll test for in the alternate hypothesis is the effect of drug A greater than the effect of drug B? So the alternate hypothesis here will be drug A is greater than drug B. So the answer here will be C.
Hello.
Yeah. Yeah.
Hello, Arpit ji. The question is like the drug A is more worse than drug B.
It does not say more worse, right? It says more active.
Here the discussion happened for the previous year assignment, not a current assignment. So you can only understand from this assignment.
Yeah, thanks, Jagdish. Yeah. So since you have not submitted the assignments, we are not allowed to give you the exact answers to the assignments. So we are solving similar questions, which will help you solve the assignments. Is that clear?
Okay.
Yeah. So someone asked for question number 10. Yeah.
Question number 6.
Question number 6. Okay. So we are given that the probability of a birth defect is 0.11, and we have to find what is the probability that no one in a family of 15 people will have that birth defect. We are explicitly asked to use the Poisson distribution. So we know that the probability of defect is 0.11. And for Poisson distribution, we have the formula P of x given lambda is equal to e to the power minus lambda multiplied by lambda to the power x divided by x factorial, where x is the value that we are trying to test and lambda is the mean of the distribution. And we know that lambda is calculated as n into p, where n is the number of events and p is the probability of an event happening. In this case, the event is the birth defect. N is the number of people in the family, which is 15. P is the probability of birth defect, which is 0.11. Therefore, multiplying n into p, we get a value of 1.65 for lambda. Now we need to calculate what is the probability that no one in the family will have the birth defect. So what is the probability that x equal to 0 given lambda is equal to 1.65? So we'll just fit all these functions. So in place of lambda, we'll just write 1.65. In place of x, we'll write 0. And we arrive at the value 0.19205. Is that clear?
Yes, sir. Can we get software for solving all these problems, sir, at the time of exam? Like GraphPad and all as those softwares are explained in the lecture.
As someone pointed out, you get a calculator. I'm not sure whether you will get Excel or any other software. I'll ask that and I'll let you guys know.
Yes, sir. If we got it is more better.
Yeah. Okay.
I just had one query. Now, answers like these, where it is expressed as a decimal, if we were to express it as a percentage or vice versa, let's say, you express it as a percentage or decimal, I mean, can there be any error, mistake recognized by the system based on the format? Like, suppose the answer to this I were to write as 19.2. That would be recognized, isn't it?
It won't be recognized. So, in general,
19.2% if I were to write.
I don't think it will accept a percentage. So how the system works is until and unless it is mentioned that you have to calculate it in percentage, you write a fraction.
Okay.
You write a decimal.
So indicate it as decimals. Okay, fine.
Yeah. So whenever you have a doubt, write it as decimals. Don't use fractions, fractions or percentages, unless they
Sir,
ask for it.
sir, can you please explain me what is the difference between the binomial distribution and Poisson distribution?
Okay. So a binomial distribution is like it is generally used when in a case when you have a number of events and you have a success or a failure of the event and you have some fixed probability of success for that event. So let's say you are tossing a coin. So you toss a coin 10 times and you want to know how many, like, what is the probability that 3 out of 10 of those times you will get a heads. So that is a sequence of tosses. So that is a sequence of events, and each event is independent of each other. So like if you get a toss on, if you get a heads on the first toss, it won't guarantee that you will get a head on the next toss, right? So that's why those events are independent. And then the probability of getting a heads or a tails is fixed at 0.5 for all of the tosses, irrespective of each other. So in that case, you use a binomial distribution. So binomial distribution gives you a formula to calculate the probability of a given event happening out of a total number of events that you have. A Poisson distribution, on the other hand, is an approximation to the binomial distribution. So sometimes what happens is the probability that you have. So in this case, the probability was 0.5, right? But in some cases, you might have very low probabilities, that is 0.0005 or 0.0003 or something like that. Then using the binomial distribution, if you take powers of those probability, it turns out to be very small. And then like when you add those up, you don't really get a correct value for probability. So what people do is they approximate that to a Poisson distribution.
Okay, sir. Got it.
Yeah. In a Poisson distribution, you have only a single parameter, that is lambda, which is equal to n into p, where n is the number of events that are happening and p is the probability of an event happening, the probability of success of the event.
Okay, sir.
So in cases where p is very small and n is very large, in those cases, you use a Poisson distribution.
Okay, sir.
Yeah.
Thank you, sir.
Yeah. Question number 7 and then 10. Yeah. So in question number 7, the question is, we have 1650 red blood cells were counted per 1 ml of blood. What is the 95% confidence lower limit for the patient's true red blood cell count? So the count here is given as 1650. And to find the confidence interval of a count data, we use a Poisson distribution. That's the basic one. Yeah. So we have a standard formula for calculating CI for a Poisson distribution, which is L plus minus T into root over of L, where L is the count, that is 1650 here, and T is a value depending on what confidence interval you are counting. You're getting the value for. So if you are using a 95% confidence interval, you use a T value of 1.96. And if you are using a 99% confidence interval, you use a T value of 2.58. So directly like inputting the values, we get 1650 plus minus 1.96 into root over of 1650. So there's a mistake here. It should be root over of 1650. Then we calculate and we get a range of values. It is 1650 minus 79 plus 1650 plus 79, which turns out to be 1570 to 1730. So what a confidence interval basically tells us is, so we have one count for the red blood cell of this person. So let's say we were to take 100 measurements of the red blood cell count of this person. 95% of the times we'll get a value which is between 1570 and 1730 on an average. Is this clear? Is this clear to everyone?
Yes, clear.
Yeah.
Yeah.
Yeah. So for question number 10, the question is, in a standardized normal distribution, what is the area between z is equal to 1 and z is equal to 2.5? So since we are not given a significance value, we'll just take the first column here, 0.00. We find, so there are different kinds of tables that give you different probabilities. Some tables will give you a probability of area, like this area. So this table gives a probability of the whole area under the curve till the z value, starting from -infinity. So here we directly see the value for 2.5 in the first row, that is 0.9938. And the area for 1.0 is 0.8413. So the area between these two will be area of 2.5 minus area of 1.0, which is 0.9938 minus 0.8413, which is 0.1525. Is this clear?
Okay, sir. Okay, sir. It's fine. It's fine.
Yeah. Yeah.
I have a
So
question.
for question number 9, the question is very direct. In a normal distribution curve, 2 sigma represents what percent of the area? So normal distribution curve is defined so that 1 sigma represents an area of 68.2%, 2 sigma represents an area of 95.4%, and 3 sigma represents an area of 99.7%. So the answer here will be 95.4%.
For the last question,
Yeah.
where we can study the standard normal distribution area between the z values. I just wanted to know that is that table means if we want to calculate for our problems which are given, where should we refer to this table?
Yeah, you can find any number of tables online. You can use one of those tables. Just beware what area the table gives you. So some tables give you area from negative infinity to the z value. Some tables give you the area from the z value to positive infinity. So the white part. Some tables will have a probability for area for this part. This table has a area for this part. So that part you just need to keep in mind and think about it. So in this case, if we refer to a table which has a probability of this area, then we'll subtract the area of z is equal to 1 from z is equal to 2.5, because area of z is equal to 1 will be larger in that case.
Okay, sir. So this table will not be used if it is a negative z score.
Yeah, you can have a table with negative z score.
So then, sir, how can we calculate area between a positive z score and a negative z score? Randomly, can you give an example?
Just a second. I'll search, I'll show you a table. Let me just share my screen again. Is the screen visible?
Yes, sir.
Yeah. So on the right side, you can see an image like you do have tables with negative z-scores that give you an area. So it's the same thing. Basically, you check what is the area under the curve under a given z-score. Let's say -1, it's 0.1578, 1587. Then you know the area for a positive z-score, and then you subtract both of them.
Sir, I have a doubt. You
Yeah.
tell that under the heading Z, there is a score -1 or +1 that is in the previous table also. We have choose from 0, 0. What is 0.01, 0.02, 0.03? if we have choose the area under the curve for 2.5 and for -1, the first value from the 0, 0. What is 0, 1, 0, 2? Can you please tell me?
What is?
The above heading of the table.
Oh,
Next
just a
to
second.
Z.
Here also you have no this line, the columns.
Yes, sir. Yes, sir.
That is the significance value.
Significance value. Okay, sir.
Yeah. So for 0.00, it's 100% significance value. Generally, when you are saying 95% significance value, you mean to check the column in the 0.05.
Okay.
Yeah. Since in this case nothing is mentioned, we chose the first column.
Okay, sir.
If something was mentioned, we would have chosen that column.
Okay, sir.
So, does anyone have any other doubts?
Sir, hello, sir.
Yeah.
Sir, Z value indicates the inner curve area or outer curve area. How we will get it?
So, in the table, whatever table you use, they should have something attached to it like this. So that will tell you what area it is showing basically. There are different kinds of Z tables. Some of them show the inner area, some of them show the outer area.
Okay, sir.
I'll show you. Yeah. So as you can see here, this table shows you the area from here to here. This table shows you an area from 0 to here. So a Z of 1 here will be area from Z of 0 to Z of 1. But an area of Z is equal to 1 here will be area of Z is equal to minus infinity to Z is equal to 1. Is that clear?
Yes, sir. But sir, if we want to calculate the area, so we have to minus it from 1.
Which area?
In inner curve area, if we want to calculate inner curve area, so after calculating, we have to reduce it from 1. That because total area is 1, right?
Yeah.
As
Yeah, you have to subtract it from 1.
I don't understand what is meant by inner curve per se. Could you just elaborate, please? Inner curve. What is being referred to?
So I basically thought it means the other part of the area that we are not looking at. Is that it? Hello?
Yes, sir. According to standardized normal distribution, that 95.4%, if we consider +2 or -2, then it is 95.4, and the remaining is 100 minus 94.5. So
Yeah.
the remainder, it is the outer curve, and 95.4, it is the inner area curve, right, sir?
Yeah.
Okay, makes sense.
That's what I thought, yeah. Okay, so question number 4. Yeah. So for, can you see the screen?
Yes, sir. It is visible.
Yeah. So for question number 4, we are given the probability of congenital blindness, which is 1 out of 8. What is the probability that 3 persons in a family have that disease? So the probability of congenital blindness here is this. And we can treat this as a binomial distribution because we have 10 events, that is 10 family members. We want to see how many, like if 3 of them have the disease. so which is like probability of 3 events happening. The probability of each event happening is a fixed constant, which is 1 by 8. So we use the direct formula for binomial distribution. Here k is equal to 3, which is the number of successes or the number of persons having the disease. N is equal to 10, which is the total number of events or the total number of family members. And the probability P is equal to 0.125. So using that, we just plug these values and calculate. Is that clear?
Yes, sir. Thank you.
Yeah. So for fifth question, calculation part, this part, right? Madan Mohan.
Yeah, yes, yes. This
Madan Mohan.
log calculation part only.
Yeah. So here we have the equation 0.91 to the power n is less than 0.05. So we take log on both sides. If we take log on both sides, the power comes out. So it's n multiplied by log of 0.91 less than log of 0.05. Now we know that log of a fraction, that is log of something that is less than 1, will be a negative value.
Okay.
So in the next step, we are dividing both the sides by log of 0.91, which is a negative value. That's why we are changing the sign.
Okay.
Then we just calculate this part using a calculator and we get n is greater than 31.76451. Is that clear?
Thank you. Thank you.
Sir, can we have to write the whole number as a 32 or 31 like that for answer?
Yeah. So the answer here will be 32. Because it's asked for a whole number answer.
So,
anyways, the
sir,
minimum number of patients can't be a fraction. Yes.
yes, sir. So we have to round it up, right?
Yeah, we have to round it up. So does anyone else have any other doubts regarding assignment 1?
I
Eight.
think
Question
Yeah.
number 8.
Question number
Last-
8.
Yeah.
Yeah, it's quite straightforward. So mode is defined as the number in a set of data that appears the most number of times. Here we can see 14 appears 3 times, which is the highest number of times. Rest of the things like 13 appears twice, 16 appears twice, 18 appears twice, and 20 appears once. So the answer here will be 14.
Yes, sir. Thank you.
Yeah. There's a problem with the assignment that you are currently given. I'll talk to the instructor about it.
Okay, sir. Okay.
Does anyone else have any questions?
So till this problem on the current assignment is addressed, I think submission may become a problem, isn't it?
Yeah. I'll notify them tonight only.
Okay, fine.
Yeah. For now, what you guys can do is if you're not able to submit, you can just write either one of the answers. I'll just notify them and most likely they'll answer your they'll accept your submissions.
Sir, by using Excel, I got the answer 14. I know
Yeah.
13 and 14 both are right, but by using Excel, I got 14. How it is possible?
That's like, it's very dependent on how they calculate the mean. So sometimes what they do is they take the larger value, the mode, sorry. Sometimes what they do is they take the larger value or take the latter value. So that's...
Yes, I also noticed this, that mode returns only one value, even in a bimodal distribution in Excel.
Yeah, that's the way they have coded it, but ideally that should not be the case. That's why we have bimodal distributions, right? So, Tafazul, yeah, there are separate tables for negative z-scores. You can get them online if you Google them. Lasna, I'll ask that. Yeah. That's something I need to ask and confirm whether you can use Excel or any other thing for the exam. Yeah. Yeah. Question 6. So here we are asked to use a Poisson distribution. We are given the probability that is 0.11 and we are given the n value that is 50. We know the formula for a Poisson distribution. We just need to calculate the mean lambda value, which is n into p, where n is 15 and p is 0.11. So we'll get a lambda value of 1.65. Then the question asks, what is the probability that no one in a family of 15 people will have that birth defect? So no one means x is equal to 0. And the lambda we have calculated as 1.65. So we just plug in the values to the formula for Poisson distribution and we arrive at a solution. Is that okay? Arunima. Yeah. For question 3. Yeah. Yeah. So the question is, we are testing if drug A is more active than drug B. What is the correct statement? So whenever we test something, we have two hypotheses generally. One is a null hypothesis and one is an alternate hypothesis. A null hypothesis is basically the accepted standard. So in this case, the accepted rule would be drug A and drug B are both equally effective. That's why H naught will be drug A is equal to drug B. And the alternate statement would be like we are testing if drug A is more active than drug B. So the alternate statement here should be drug A is greater than drug B. So here like greater than means activity of drug A is great, like better than drug B or something like that. Is that clear, Parul?
Sir,
Yeah.
thank you so much, sir.
Yeah. So,
Sir, in question number 3,
yeah.
If in exam the option comes that drug A, our null hypothesis is drug A is more active than drug B,
Yeah.
and alternate hypothesis is that drug A is less active than drug B. So would this be correct?
It depends. So generally, until it is proven, you generally say both of the drugs have a similar kind of effect. But if some studies show a drug to be better than some other drug, so let's say we were to say that some headache medicine A works better than other headache medicine B, and that is quite accepted in society. In that case, you can have the null hypothesis that drug A has a better action than drug B. And
Okay.
if you want to test, like alternate hypothesis can be anything. So if you, it depends on what you want to test. So if you want to test if drug B is more active than drug B, then alternate hypothesis can be drug B is greater than drug A.
Okay, sir. So if the condition in the question changes, accordingly, we have to justify. Okay, sir.
Yeah.
Okay, sir. Thank you so much.
Yeah. Yeah, Tafazul, the VR testing relates to the alternate hypothesis. So what we want to test should go into the alternate hypothesis.
Sir, could you tell me alpha error and beta error? What is
Alpha error and beta error. So there are type 1 and type 2 errors basically, right?
Yes, sir.
Yeah. So you have two hypotheses. One is a null hypothesis, one is an alternate hypothesis. So whenever you test hypothesis, we set a significance value of 95%. So that means like with 95% confidence, we can say whatever we are saying is true. The rest of the times, it might just be ki we are false. So sometimes what happens is there is a small difference which we are not able to see because like our testing somehow fails. So in that case, what happens in reality, there is a true difference between two things. But while we measure it, we are not able to get that difference. So in that case, we get a false. So we get a negative value because we are not able to perceive the difference. But the actual value is there is a difference. So that's called a false negative or a type 2 error. So in a type 1 error is a false positive. In that case, what happens is there is no difference in the thing that we are testing, but because of some fault in our test, we are getting some difference. That's a false positive or a type 1 error. So generally, like if you're testing for two differences between two populations or something, and you have a very high sampling rate, then even minute differences in the mean of the population can be very significant. So in that case, you are more prone to make type 1 errors, which are false positives. So even if there is no difference between the population, you tend to see a difference in the population. But if you have a very low sampling rate, a less number of individuals from different populations, and you want to see a difference between the populations, then most of the times you get a false negative or a type 2 error, where there might be a difference in the populations, but you're not just able to see that because of your sampling rate. Is that clear?
Yes.
Yeah. So, do we have any other questions? Okay, so
I think Arpit bhai, you have given a patiently all the answer repetitive time. Thank you very much for clarifying all the questions by the all the research fellow or the whatever the other persons in the course.
thanks a lot for being here and for asking the doubts and everything. It also helps us to like read up stuff and work on things. This kinds of helps us also in a way. Yeah. So thanks a lot, everyone. I'll ask about the Excel sheets and the mean question in the assignment, and I'll get back to you guys. Okay. We'll meet
Thank you, sir.
next week at the same time. Yeah. Thanks.
Thank you, sir.
Thank you
sir.
so much.
Thanks for
Thank you,
patience.
Thanks
sir.
a lot.